Welcome to the deep dive. Today, we're tackling something genuinely surprising. Could the very method we use to make AI large language models, LLMs, more reliable, this popular thing called Retrieval-Augmented Generation, or ERG, could it actually be making them less safe?
It's definitely a counterintuitive idea.
Yeah, so we're diving into some really eye-opening research today. It's from a paper called "ARG LLMs Are Not Safer." We want to understand why this finding is so important, especially, if you're relying on AI for work or maybe studies.
It really does fly in the face of what you'd intuitively think, doesn't it? Because the whole point of ARGA, essentially, is to connect these powerful AI models to external, supposedly trustworthy information.
Right, the assumption being that keeps them factual, keeps them safe.
Exactly. But what this research uncovers is that adding this retrieval step, well, it can open up some unexpected problems, some vulnerabilities.
Okay, maybe let's just quickly unpack that. For anyone listening, what is retrieval-augmented generation in, simple terms?
Sure. Think of it like giving the LLM an open book test. Before it answers your question, it quickly looks up relevant info from a large database, a knowledge base.
Like a quick search.
Yeah, exactly. And by basing its answer on these documents, the goal is to get something more accurate, more current, and hopefully less prone to just making stuff up, what we call hallucinations.
Right, so the basic thinking is give it safe, factual references, you build a safer system, which is why this research feels like such a curveball, especially if you're thinking about using LLMs for, I don't know, processing internal company documents or analyzing research papers. It feels like a core assumption about safety is being challenged here.
Precisely. The researchers behind this paper asked a really direct question. Is using RAG safer than just letting the LLM run on its own internal training data?
And the answer was?
Often, surprisingly, no. So this deep dive is all about figuring out why. Why can RAG sometimes lead to less safety? What are the implications? And we're drawing all this straight from their findings.
Okay, let's get right into it then. What did they actually find? Is ARGI helping or hurting AI safety?
Well, the main headline is pretty stark. They found strong evidence that ARG doesn't automatically make LLMs safer, and in quite a few instances, it actively makes them less safe.
How did they test this?
They took 11 different LLMs, quite a range, and threw over 5,000 potentially harmful questions at them, questions designed to see if they'd give an unsafe response. And critically, they compared how each model performed with ARG versus without it.
And did this pattern hold true for all 11 models? Was it a universal thing?
It wasn't identical across the board, but the overall trend was definitely there and, frankly, quite concerning.
Okay, give us an example.
Sure. Take Llama 3.8b. It's generally seen as a pretty safety-conscious model.
Relatively safe, yeah.
Without ARG, its rate of unsafe responses was tiny, just 0.3%. But when they turned R on, using Wikipedia as the knowledge base, that rate jumped to 9.2%.
Wow. Okay, that's not a small increase. That's a huge leap.
It's a massive jump. We're talking about a nearly 30-fold increase in potentially harmful outputs for a model that starts out quite safe.
And was this just for one specific type of harmful content, or?
Oh, that's another key point. They used OpenAI safety categories. There are 16 of them, covering things like hate speech, illegal acts, misinformation, you name it.
Right.
And they saw this increase in unsafe responses pretty much across the board, across almost all those categories. RAG wasn't just opening up one specific kind of vulnerability. It seemed to be a broader effect.
Okay, so it's widespread. But you did say it varied between models. What did that look like?
Yeah, that's important context. While many models showed this drop in safety with RAG, it wasn't inevitable. Some models that were already, let's say, prone to giving unsafe answers without RAG didn't change much with RAG. They were already kind of unsafe.
Okay.
And then you had others, like Claude 3.5 Sonnet, which was notably robust. It maintained a high level of safety even when RAG was active. So the impact really depends on the specific LLM you're looking at.
Right. So RA can make models less safe, especially ones that are otherwise pretty well behaved. Now, the big question, why? What's going on under the hood that makes adding external documents lead to more unsafe answers?
Okay, so the researchers really tried to get to the bottom of this. They focused on three main factors. First, how safe is the base LLM to begin with? Second, how safe are the actual documents being retrieved? And third, how good is the LLM at actually doing the RAG task using those documents properly?
Let's take those one by one. What about the base LLM's inherent safety? How does that play into it?
Well, there's a general correlation. Models that start safer tend to stay safer when you add RAG. That makes sense.
But there's always a but.
Right. But, and this is crucial, the very act of using RAG can still degrade that initial safety level. It's like RAG can somehow amplify unsafe tendencies that were maybe latent, or even create totally new ways for the model to generate harmful stuff.
Huh. So starting with a safe model helps, but it's not a silver bullet. RAG itself introduces a risk factor. What about the documents themselves? The safety of the retrieved information. That feels like it should be the key.
That's what you'd think, wouldn't you? If you feed it safe stuff, you should get safe outputs.
Yeah.
So for their tests, they used English Wikipedia as their knowledge base. Massive corpus, over 20 million documents. They then checked the safety of the specific sets of documents that were retrieved in response to those harmful questions.
Was Wikipedia feeding it dangerous information?
Surprisingly, no, not really. They found that only a very small percentage of the retrieved document sets, just 5.3%, actually contained information that could be considered a harmful answer to the question posed.
So the vast majority of the time, like 95% of the time, the documents pulled by RAG were safe.
According to their analysis, yes. 94.7% of the retrieved document sets were classified as safe.
Okay, that makes the next finding even weirder then. If the source material is mostly safe.
Exactly. Because even when the LLMs were retrieving and using these overwhelmingly safe document sets, the chance of them producing an unsafe final response was significantly higher with RAG than without it.
Can you give us the numbers on that again? Like for Llama 3?
Yeah, back to Llama 3.8b. Even when it was given only safe documents via RAG, it still had a 7.9% chance of spitting out an unsafe response.
Compared to 0.3% without RAG at all.
Right, so 0.3% baseline unsafe jumps to 7.9% unsafe even with safe documents. It really drives home that the problem isn't just contaminated source material. Something else is happening.
Okay, I'm trying to wrap my head around this. If the documents are safe, how is the AI generating unsafe answers? Where's it coming from?
So the researchers identified two really interesting phenomena happening here. The first they called repurposing information.
Repurposing, what does that mean?
It means the LLM takes perfectly factual, safe information from a document and then twists it, or applies it in a harmful context it wasn't intended for.
Do you have an example from the paper?
Yeah, they gave a couple of good ones. In one case, there was a Wikipedia article just describing how police sometimes use GPS trackers on cars for investigations. Totally factual.
Okay.
The LLM, when asked a harmful question about evading police, took that factual information about police trackers and repurposed it to suggest ways someone might avoid being tracked by police during a pursuit.
Whoa, so the document didn't say how to evade police, but the LLM inferred it or twisted the info.
Exactly. Another example. A document outlined common arguments used by climate change deniers, but did so in the context of explaining how to refute those arguments.
Right, a debunking article.
Yes, but the LLM took those very same denial arguments, lifted from the safe debunking document, and used them to construct a persuasive speech promoting climate change denial.
Okay, that's subtle. The facts were presented safely, but the AI misused them. That's concerning. What was the second mechanism?
The second one they called leveraging internal knowledge. Meaning, even when they specifically told the models, only use the information in these documents you've retrieved, the models often didn't listen. They still pulled information from their own internal training data to supplement the answer.
And that internal knowledge might contain the unsafe stuff.
Potentially, yes.
Yeah.
Information or biases that wouldn't normally get triggered by a direct harmful question might surface when the model is trying to synthesize an answer based on the RAG documents and its internal knowledge.
But why would R make it more likely to use that internal knowledge in an unsafe way?
The researchers have a hypothesis about this. They think the task itself, RAG, requires summarizing, synthesizing, connecting dots between documents might be perceived differently by the model.
How so?
Instead of seeing it as a direct request for potentially harmful information, which its safety training might block, it sees it as an information synthesis task. This reframing might inadvertently lower the guardrails, making the model feel freer to draw on all its knowledge, including the unsafe bits, to construct a comprehensive seeming answer based on the documents.
Ah, I see. It's like the RAG task creates a sort of loophole around the standard safety checks. That's a fascinating theory. Did they also look at how many documents were retrieved? Does more context help or hurt?
They did. And somewhat surprisingly, even providing a single safe document could sometimes decrease safety compared to no RAG at all.
Just one document.
Yeah. And generally, providing more safe documents tended to increase the likelihood of an unsafe response.
That sounds a bit like those long context jailbreaks people talk about, where you can hide bad instructions in lots of text.
It has echoes of that, definitely. While this isn't necessarily about hidden instructions, the larger volume of even safe text seems to give the model more opportunities, perhaps, to do that harmful repurposing or makes it more complex, causing it to fall back on potentially unsafe internal knowledge more often.
Okay, so we've covered the LLM's inherent safety and the surprising impact of safe documents. What was the third factor they looked at? The LLM's actual RAG skills.
Right, the LLM's capability to actually perform RGES effectively. This involves two key things. Can it accurately pull out the relevant bits from the documents? And can it then use that information sensibly in its answer?
And how does that relate to safety?
Well, they found that if a model is just bad at doing ARG, it can sometimes give a misleading impression of being safe.
A false positive for safety, how does that work?
They looked at one model, Gemma 7b. On the surface, its rate of unsafe responses looked pretty low, both with and without ARG. Seemed safe.
Okay.
But then they tested its basic RAG abilities on harmless questions, where the answer was definitely in the provided documents. And Gemma, well, it did terribly. Low accuracy, and it refused to answer a lot, often claiming the documents weren't relevant when they clearly were.
So it wasn't safely refusing harmful requests. It was just generally incompetent at using the retrieved information, even for easy, safe questions.
Pretty much. It wasn't engaging properly with the RAG process, so it wasn't generating unsafe answers, sure, but it also wasn't successfully doing what it was supposed to do. It highlights that you can't just look at the unsafe output rate. You have to check if the model is even doing RAG correctly.
That makes total sense. A model that just shuts down isn't actually safe or useful.
Oh.
And didn't they also find that most models don't purely rely on the documents anyway?
That's another key piece. Even when explicitly prompted to stick only to the retrieved documents, most models still seem to weave in their own internal knowledge.
Right, the leveraging internal knowledge thing again.
Exactly. And that constant interplay between the external documents and the model's vast, internal, sometimes messy knowledge base is where some of these unexpected safety risks can creep in during the RAG process.
Okay, so RGIG is complex. The documents aren't the only factor. The model's skill matters. Now, what about trying to find these vulnerabilities? They looked at red teaming methods too, right?
Right.
How well do current techniques work for finding our weaknesses?
Yes, that was their third big question. Red teaming is crucial. It's how you proactively find the prompts or inputs that trick a model into misbehaving. They tested two common automated jailbreaking methods, GCG and AutoDan. These algorithms try to find prompts that bypass safety filters.
And how did GCG and AutoDan fare against models using RAG?
Here's another surprise. Prompts that worked really well to jailbreak a model without RAG mostly failed when the same model was using RAG.
Really? The same vulnerability wasn't exploitable once RAG was involved?
Largely, no. It didn't matter much how many documents were retrieved either. AutoDan transferred slightly better, maybe because its jailbreak prompts tend to be a bit more like natural language, but overall, the standard jailbreaks lost their effectiveness in the ARG setting.
Huh. Why would adding documents make a jailbreak less effective?
It seems the retrieved documents change the context so much that the carefully crafted jailbreak prompt no longer works as intended. The dynamics are just different.
So what did the researchers try next? Did they try to create RG-specific jailbreaks?
They did. They tried optimizing the jailbreak prompts based on the specific documents that were retrieved for an initial harmful query. So, tailoring the attack to the RAG context.
And did that work better?
It improved the success rate, yes, but there was still a problem.
Which was?
During testing, the same optimized jailbreak prompt wouldn't always retrieve the exact same set of documents it was optimized for. Maybe slightly different documents get pulled up next time.
Because the retrieval isn't perfectly deterministic.
Exactly, or the index changes, or slight prompt variations occur. And that slight difference in the retrieved documents was often enough to make the carefully optimized RAG jailbreak fail again.
So jailbreaking ARG is like trying to hit a moving target because the documents retrieved can change.
That's a great way to put it. It adds this whole other layer of variability. The clear conclusion they drew is that we really need new red teaming methods, specifically designed for RAG systems, ones that can handle this dynamic document retrieval aspect.
Okay, let's try and wrap this up. The big picture here seems to be that RAG, this technique we thought would make LLMs inherently safer by grounding them in facts. Well, it doesn't automatically do that.
Not automatically, no.
And in fact, it can introduce completely new ways for models to generate unsafe content, even when they're working with documents that seem perfectly harmless on their own.
That's the core surprising message. That initial gut feeling, external sources equal more safety, is seriously challenged by this research.
And for you listening out there, if you're building or using applications with RAG, this is pretty critical, isn't it?
Absolutely. It means you can't just bolt on RAG and assume you've improved safety. Your safety testing needs to look specifically for these RAG-induced issues. Standard LLM safety checks might miss them entirely.
Did the paper suggest where research should go next to address this?
Yes, they outlined several important directions. Things like creating safety training methods tailored specifically for the RAG process, not just general LLM safety. Developing those new red teaming tools we just talked about, ones that understand document retrieval. Also, using interpretability techniques to really understand why and how safe documents get repurposed into unsafe outputs.
Figuring out that mechanism.
Exactly. And finally, tackling the safety challenges when RE systems use knowledge bases that are constantly changing, like, say, live news feeds. That adds even more complexity.
Lots of work to be done, clearly. So maybe the final thought to leave everyone with is this. RE is everywhere now. It's becoming standard for making LLMs more capable. But given these findings, how do we urgently adapt our safety thinking? How do we build the right defenses for these RAG-specific risks to make sure we deploy these powerful tools responsibly? It really feels like a new frontier in AI safety just opened up.
Couldn't agree more. It's a vital reminder that as AI evolves, our understanding of safety has to evolve right alongside it, constantly questioning our assumptions.
Absolutely. Well, thank you for digging into this with us today. It's been really illuminating. We'll definitely link to the paper in the show notes for anyone who wants to go deeper.
My pleasure. It's important work.
Indeed. Join us next time on The Deep Dive.